All right, so you are now prepared to do a number of things related to thermochemistry for the reactions that you have. So you can measure a temperature change, and as long as you know the identity of the substances, you could calculate Q. You could measure a volume change and use that information to calculate W. And then combine these, right, to calculate your change in internal energy. And that sounds like a lot of work. So my question is, but what if you didn't have to? And just to let you in on a secret, a lot of chemists were really quite lazy. So if there is a way that we could make this easier to deal with, we absolutely will. So let's kind of brainstorm, take a minute to think about how you could constrain the system that you're looking at to make these things easier to deal with. So, constrain the system. And this one, it's pretty cool in concept. It's a little harder in execution. But what if we had a constant volume? If you go back to the last video, we just talked about how to calculate pressure volume work, which relied on a change in volume. Well, if you do it at constant volume, your delta V is 0. So we could have a situation where we just don't have any work, and then everything we measure that's heat is the same as the internal energy. That makes things very easy to deal with in terms of numbers. Now, there's another constraint that we can do, and that is to do a reaction at constant pressure. And this is not as straightforward when it comes to just knocking something out of an equation, so we'll say a little more involved. But it's significantly more practical because if you think about it, this is the type of chemistry that you would do in lab no matter what, right? If you're open to a benchtop when you are doing your chemistry reaction, you have a constant pressure situation. It's all at about 1 atmosphere when you do it. Now we end up tweaking the equation just a little bit, but this constant pressure constraint is huge, and it's going to carry us through a few more concepts and videos. So this is where we put it all together, and as you go to look at the next videos, you'll see a video where we deal with constant volume and then we deal with constant pressure.